Hello everyone, welcome to the week 0 of Introduction to Polymer Physics course. This is a tutorial session where I will discuss some of the problems and obviously clear your doubts and questions. Let us wait a few minutes so that everyone can join. We'll start after 5 minutes. Hello everyone. So, welcome again to week 0 of Introduction to Polymer Physics course. This is a tutorial session, the 0th tutorial session where we will not go deep into the course subject. We will discuss some of the prerequisites, some of the basic concept of the required for this course, and we will discuss a few problems from the week 0 assignments, which can be considered as week 0 assignments. This is a tutorial session which will occur on every Friday, 6 to 7 p.m. The links will remain same. I will be uploading the videos. You already know about this, I guess. I will be uploading the videos on some link which you have access after this session also. I will upload the whatever online notes notes I am writing here on my iPad. I will be sharing that also. And mostly I will try to discuss the previous week, as in on the previous week, whatever has been covered in the online session. I will be addressing those and addressing your concerns, your doubts, whatever question you have, you can ask me, obviously. Myself Subhadeep Datta. I am a research scholar at IIT Bombay. My research field is soft matter physics, which deals with polymer physics, in which polymer physics is a large part of soft matter physics. Also, it deals with some of the biological materials, our cells, tissues, bodies, everything. We look into these materials from a physics point of view. I am a physics graduate. I have done MSc in physics. So this comes some kind of interdisciplinary subject where I look into these biological phenomena, polymers, soft materials, cells from a physics point of view. We try to quantify forces, responses to the forces, and some phenomena happening inside cell. We try to address that via some simplistic model, and so on. The course you are learning here, polymer physics, this has also a great application in the field of biological physics, because as you already know, we have a large polymer inside each and every of our cell, which is DNA. And not only DNA, there are RNAs, microtubules, actin filaments, and so on. So in that sense, polymer physics is important, and we will be mostly concentrating on the physics part of this polymer. We will not go deep into the chemistry of the polymers, structure of the polymers, formation of the polymers. We will not consider that. We will try to build on some models which can mimic the properties of our real world polymers. In some sense, they cannot really reproduce all the properties, but in some sense they can capture some of the properties and some of the say some of the like solubility and whatever their phase transition of the polymers and so on. We'll come into that later in the subject. Today we'll discuss some basic questions, mostly from the prerequisite of the subject. You will need statistical mechanics to a great extent in this subject, because we'll be talking about large polymers which are like already, we don't call just an ensemble of monomers joined together, which is like 10-20 monomers together. We don't call them a polymers. It is should be greater than 100 monomers assembled together to call it a polymer, and also it should have a repeating units. It is not that you joined small different kind of monomers and they form a large molecule which is like a protein. We don't call them a polymer. So the criteria is it should be large in length, large assembly of a monomer, and there should be a repeat sequence, right? Okay. And so to start with, let me check the recording is perfect or not. Yeah, it's going perfect. So the first question today we will discuss that which of the following is a branched polymer. Now, what is branched polymer? So branched polymer is branched polymer. This is the main concern of this question. So branched polymer means you have a chain from which branches are coming out like this. So this kind of polymer, if you see, this is a branch polymer. Now what happens if it is a branched polymer, then due to these side chains it cannot be a very compact assembly of monomers, because there will be steric hindrance appearing from these side chains. This kind of side chains will give some steric hindrance and which will resist to the polymer to become a very compact assembly of monomers. So by construction the branched polymer will be a low density polymer, because it will have a comparatively large volume and effectively a low density. We will see low density polymer. Yeah. So as you see in this question, the option is low density polymer, which is option 1. It will come here. Then the next, we will come to the next question. On the basis of mode of formation of polymers can be classified as. So you already know there are two kind of polymer possible. Construction of polymer possible. So we'll divide in two part. Like if we say construction of polymer, so one is addition polymers, another one is condensation, right? Yeah. So in addition polymers, what happens, you have a monomer which is say A, it will attach to a AN and it will create a AN plus 1. So each time, so the starting step will be always like two monomers will attach, it will give A2, and then at some point there will be a large assembly of N monomers, N repeat sequence, which is the AN here, and then again one A will join to that and it will form AN. So each time one molecule is attaching on repeat unit, one monomer, it's attaching to the assembly of the monomers, and it is called addition polymer, because we are adding one monomer each time, correct? On the contrary, if you see the condensation polymer, it is slightly different, because here you will see say MX is a polymer which has X monomer, My is another polymer which has Y monomers, and they will join together, they will react and form MX plus Y, which has X plus Y number of monomers. So you can see the fundamental difference between two processes. Here we have a large assembly growing, and each time one monomer is coming into and attaching, reacting to the assembly and attaching to that and forming a bigger polymer. But here independently two bigger polymer was forming, and they kind of merged to form a bigger cluster, bigger assembly of monomers, which is mx plus y, right? Any question at this point? We have discussed few questions. Any question at this point? I will wait for some time. Okay, let's proceed. So in this question, on the basis of mode of formation of polymers can be classified addition polymers only, condensation polymers only, copolymers. Copolymers is something else, some other classification. Copolymers appears. What is copolymers? Copolymers appears. So let me first talk about homopolymers. Homopolymers, which is like you have one monomer and there is only one kind of monomer. So the polymer is like a long sequence of A. So this is homopolymer. But copolymer is something where you have something A and B, say A, B, something like this. Or it can be like a block of A, then block of B, something like this. Both of them. But due to the two different kind of monomers present in this kind of polymers, it called copolymers. But really this classification is not based on the formation. This is based on the type of monomers present in the polymers. So we are considering only based on the mode of the formation, right? So addition polymers obviously yes, condensation polymers yes, both of them yes. So obviously the choice is last option. Now in the next question, in addition polymer, monomers are used. They are what kind of compounds? So in addition polymer, so if you remember, we have already discussed about addition polymer. In addition polymers, what kind of monomers are used? So addition polymer is like you have AN already, you will attach another one and you will form AN plus 1. This is addition polymer. We have discussed already here, right? So to have one example of addition polymer can be with our day-to-day experience with this polymer. We have day-to-day experience, which is polyethylene, something like this. So this part is the repeating unit, and N is the number of repeat units, right? So in this case, the monomers were ethylene molecule, which is like something like this, and this has this double bond. Now any hydrocarbon, so this is ethylene. So in any hydrocarbon where there is a double bond, this molecule is not saturated. So these hydrocarbons, these are called, let me say in another way, these are called unsaturated hydrocarbons, correct? So these unsaturated hydrocarbons has a possibility that they will take hydrogen, so and they become saturated. So generally this kind of molecule is called saturated hydrocarbon, and these are the unsaturated hydrocarbons. Now addition polymer is mostly formed when there is a unsaturation present, like this double bond. So the question here is asked that in addition polymer, monomers are used is This will be unsaturated compounds, right? Any question at this point? Okay, so let's come to the next question. Here, the question you ask is a trivial question. Polymer formation of the monomer we have already multiple times discussed. They're basically condensation of the monomers. The many monomers will be in the solution, maybe in liquid phase or in a gaseous phase. They will condense and form a big polymer. So it's a condensation reaction. So hydrolysis of monomers is not possible. Conversion to the monomer ions not feasible, because the bonds involved in forming polymers is mostly covalent bonds, not ionic bonds. The coordinate reaction, no. The coordinate reactions, coordinate bonds, they are mostly not covalent bonds, and so the most appropriate option in this case is the condensation reaction, right? Okay. Again, all of the above, because yeah. So if you just, so these questions mostly are focused on the polymer structure, polymer chemistry, physical chemistry of the polymer, solubility, and those properties. In this course, in this particular course, Introduction to Polymer Physics, we will be considering about the physics of the polymers. So we are not basically interested in what is the structure of this polymer, what is the molecular structure of this polymer. We will not consider that, okay, this is a polyethylene, so it has CH2C, H2 as monomer, which forms like these forms are repeat units, and from that it creates polyethylene. But we will not consider about the C and H, what is the type of bonds here, what is the angle between these. These are we won't consider those as in very detail. This molecular basis we won't consider. What is the interaction between C and H2? We won't go deep into the molecular details. So we will consider polymer as a chain of monomers. So there will be monomers, which is and polymer is a chain of monomers, like this. And we will be considering what is the physical properties, how it is dependent on the stiffness of this chain, flexibility, in other words. We will be considering those cases. So we will build on some kind of model, which is a random walk model, and so on. And then maybe some freely rotating chain model, which will introduce stiffness. These are the models we will be mostly working on. We are not really interested in the polymer chemistry. We are mostly interested in polymer physics, right? Okay. Okay, so any question today? I will wait for some minutes. You will obviously work on your assignment, current assignment, and you will ask whatever doubt is. You can mail me at any point of time if you have doubts. My email ID I will write in the chat box, and we'll meet next Friday at the same time, like 6 to 7 p.m. We'll meet and discuss about the next assignment. And any doubt you have from the videos, we will obviously address those. Right. Yeah. any doubts today. You can raise hand or you can write in chat box, whichever way you like. Okay. Okay, I stop the recording at this point of time, and if you have still doubt, you can obviously ask me.